Hi, welcome to the small shed and the Cyclekart build. This week I want to have a look at the chassis and hopefully get the whole project moving on a stage further. See you in a minute. Right, now I started thinking about this project in April 2021. That was when the first germs of an idea came into my head, and I think it wasn't until probably 2 or 3 weeks later I decided I was going to have a crack at building the Cyclekart. It's now mid-October 2021, so it's just about 6 months have gone on since then. And all I've managed to achieve so far is effectively the mock-up. I've had 6 months of thinking, planning, researching, but I think I've reached the point where if I go any longer it's procrastination, not research, or it's not perfecting the design any further. The mock-up was great for finding out whether I could get in or out of the cart and roughly that it was technically possible, but it's reached the point now where it's not much help, and you can't sort of micromanage the project on a bit of 3x2 wood. I really need to get some real aluminium section, get it sorted and start and build a chassis. So I think it's time to stop fannying around. Let's go over into the shed. I'll have a quick run through about what I'm using for the chassis, how it's going to be used, and we'll get an order, get sorted, and hopefully the stuff will be on its way. Right, now it's perhaps a bit unfair to say I'm procrastinating. I have got a fair amount of stuff purchased. Certainly I've bought the engine, I bought the TOV converter. I've actually just had some bearings arrived which will take the rear axle and bolt down to the chassis rails, because the axles are above the chassis rails in the 7. So that's a bit more work done, and I've also had arrived some odd washers which I will go into a bit more later when you can see the relevance of them, but I've got some washers arrived as well. So stuff is happening, stuff is moving along, and I've just been waiting really to sort of press the button, and the chassis is perhaps the main place to start with that. So let's have a very quick look at chassis. Now the traditional Austin 7, pure in its own sort of right, had a frame which was essentially 2 rails that tapered inwards, and the spring was mounted at the front. There were cross members to sort of brace it up a bit, and the springs just literally came out of the back of the axle, out of the chassis and into the axle differential and out that way, and they were sort of housed inside the frame. And on the front you had a spring which hung off the front of that chassis, and a beam axle which ran across, and that was, there's another cross member about there, that was triangulated back into the centre to the main cross member there, so that it would swivel that way and it would bounce up and down. Now the race cars are nothing really like that. In the early days what tended to happen was that the boys soon discovered you could put the spring upside down, mount it below the axle, and that would lower the whole of the front end, and you could flatten the back springs and lower it. And the actual first side valve racers had a similar arrangement with this frame and the axles, frame and the springs coming out meeting the axle, and then they had a modified front end. But the twin cam is slightly different. It still has the A-frame like that, but the springs actually come from out on the side there now on them, and they go out to a back axle across there. But the shape is essentially still the same. You then have a front axle on the twin cam, which is mounted off a spring perch on the front, and two small stub radius arms there, two on each side, which retain lateral sort of support on that axle. And that's where we're going with the current arrangement. So I need two chassis rails to go out that way. I've got an unsprung rear end, so effectively we'll just be going across with these bearings sitting on top of the frame rails, and the axle will go through. Front end is going to be as close as I can get it to the Austin 7 twin cam racer, and I mentioned that, or I either have mentioned it or will mention it in a future video as to how I'm going to deal with that. So that's it. It's very simple. The original ones are a bit whippy because there's not a great deal of torsional sort of rigidity anywhere in it, despite having some cross members. And what tended to happen, of course, is that with a leaf spring that's curved like that, sitting on there, when you flatten the suspension on one side, it straightens the spring out, which makes it slightly longer, which pushes the back axle slightly at an angle, and you get all sorts of odd handling, to put it mildly. But that was something that the flattening the springs out and lowering the cars helped with no end. So let's have a look at what we're going to use to emulate the twin cam racer chassis rails. Right, now this shed you may have seen in the background is basically full of carts, both the underbench storage there, the miter saw unit, the lathe, the vacuum and sanding station there, and there's a unit underneath this router table here. They're all built out of the same stuff. It's 40/40 aluminium section. It's incredibly strong, incredibly rigid and reasonably light. Let's just have a quick look at how it's all joined and how the system works. Now you can get a number of sections. These things are all generic sections that go from, I think 2020 is the smallest they use on a lot of 3D printers and things like that, and laser cutters, through 30/30, 40/40, 45/45, I'm not sure how much bigger it goes than that, and you get combinations of the two, so that's 40/80, that's two of them together. You can get 41/20, 41/60, 30/60 and so on. So for the main side rails I'm going to be using 40/80. Not because it needs it for the strength, I think I can get away with it for less than that, but 40/80 is about right for the depth of the rails that I want. It scales right for the chassis rails on the 7. And how this stuff works in the carts and the like is that you have a corkscrew which is threaded into that end section there. Just do one. You can get an idea of how relatively easy and strong it is. Just drive a corkscrew in. That effectively cuts a groove into a thread into the core, and then you slide your section onto it with a piece with a hole in it, if I've got one here, and then you drill a hole 20mm in from the end. That slides onto the head of the bolt like so. Get it on loosely enough.
that's it, and then you push a fixing through with a Torx bit, tighten that up, and you have got a joint which is as strong as anything you're ever going to need. I've got one very minor reservation, and that is that I don't know how these things will stand up to use in a car chassis effectively, but I really don't think it's going to be a problem. There are more lightweight solutions with brackets with grub screws, Allen screws in, that will fix this stuff together, but I don't think that is suitable for certainly heavy use mounting engines and things, though it may just possibly be that it'll be useful for mounting ancillary sort of work on things like side rails and things. I don't know. That is quite a good fixing, but of course it relies on that metal bracket there, and there is a little bit of give in it. You'd probably need to put one either side, and even then certainly not as good as having the core screw with a 12mm bolt through it threaded into that section. So that's how we're going to put it together. I've got to go very slightly different with that, in that that will give you right angles, and I don't want right angles. I want to be going at effectively 5 degrees off with the slope on these rails, and so it means I'm going to have to slightly change the whole way that this thing is used. What I'm going to have to do is to bolt right through the section from the outside with a longer bolt and trim the ends of the section. Get that one out. And trim that by 5 degrees so that exaggeratedly you get that. And then you'll push a bolt through into the core the same way, but it'll be going through that outer rail right the way through, which you can probably already see then raises another slight problem, in that you're putting a bolt at 5 degrees to the face of that metal, which won't really mechanically be very sensible or good. And that is where these little jokers come in. What these are washers that have a 5 degree slant on them, and so what that means is you can push that through there and it will land onto that metal and straight through with decent sort of spread of load. So that's what those are for, and I'm hoping that will get me out of the main problem. So that's what I'm using, that's the metal. This stuff is very strong. I've cantilevered this on 4080 like that. $500mm out, and sat 100 kilograms on top, and the deflection on that top has been millimetre or two, so there's no great problem at all with strength in this, and that's with 4040 hanging off. 4080 is going to be more than overkill. It's purely and simply there for aesthetics rather than mechanical strength. So let's get some ordered. I do what I normally do, go to my favourite supplier, KJN Fabrications over in Leicestershire, and we will go onto their website and see what we can do to get that sorted. So there's two different sorts of profiles that they supply. There is what they call box Rexroth and the IR range, and they're both slightly different. I tended up until now to always use the box Rexroth, and if you go into that one, it will come up with aluminium profile, and you can choose different slot sizes, 6mm, 8mm, 10mm. I normally use 10mm, and that will give you that. And then you can go through 45, 45, 45 with 3 sides covered in and 1 side with the slots in, and so on, all the way down, half curved, 45 by 60, 45 by 90, and there's a huge range, 45, 90 by 90 by 45 angles. Gives a huge range of stuff. If I go to the plain straightforward 40 40 40 that I'm using, which is there, configure the product, it'll tell you that it gives you its weight, 0.15 kilogram per meter, £1.96 for that piece, but it says it's £9.96, £9.66 a metre, I mean, plus VAT, plus delivery, and then there's a cutting charge of 99 pence per length. So if I put in there that I want 2 metre length, which is what I want a couple of, calculate, that's £20.31, 2 of those, and add it to basket. And then we just go on through all of that, and it will give you a running total of how much this lot will come to. The way I'm going to be different is that I am going for the IR range for the main frame rails, the IR compatible, and that's because they do an 80/80, which is like that size, but it's got a smooth side on it on one side, which is what I want on the outside of the cart. I can get inserts that fit in and look roughly flush, but you've still got grooves and bumps in it here, and I wanted something totally flush on the outside, so I've gone for the other section. It's not quite compatible, but on the other hand I'm not actually using it to fix like this, I'm just drilling straight through it, so I don't foresee a problem with that. So if I go into the IR profile, I then go into 8mm slot, because they don't do a 10mm slot on that, and I go to the 40/80 I want. There's less range in this, but there are some differences, like that's the one, 40/80 2N IR profile. I'm not going for full 2 metre lengths on that because it's the chassis rails and I only want 2 of them. I think they're currently at 1700mm on the wooden mock-up. I'm going to order 1800mm. That gives me a little bit of room to cut. I've got to trim the ends to 5 degrees off, and I might want to just stretch the wheelbase a bit. I'll want 2 lengths, and we want them 1800 long, and they are £47.64 each, excluding VAT, which again, a bit of a nasty, but there you go. And delivery again, which we'll come to on the end. So we'd add those to the cart, and so on we go on until we get to the checkout. So there I am with all of that. I've got 2 lengths of 40/80 for the chassis rails. I've got 1 length of 40/80 just for the cross members and engine supports and that, which are, that's the old box Rexroth. It's about £7 a length cheaper, that. I've ordered some T-slots and nuts which are to hold the body down. I've ordered 2 lengths of 40/40 aluminium. I don't think I'll need all of that, but it's useful to have in the shed anyway. I've ordered some 40 by 120, which is for the engine to sit on, because the holes in the motors are 80mm apart. So 40 by 120 will give me fixing through 2 of the webs down that way, for bolts on the motor, and that'll incorporate into the rest of the frame, I hope. And I bought 4 lengths of infill which clips into the slots just to tidy things up on the inside, I think. Whole lot of that, £215.71 plus carriage £24.99 plus VAT £48.14, £288.84. Let's see whether it's a wise investment or not. Right, well, I'll talk about milestones. I think that's another significant one. We've actually ordered something now that will be fairly fundamental to building the cart. While I wait for that to come over the next few weeks, we'll get a few other things looked at, like springs and all sorts of other stuff that I need to sort out, and once it arrives we can obviously make a meaningful start on building the thing. Hope it was of interest. Look forward to seeing you next time. We'll be doing something different on the cart. I'll see you then. Bye.